morning everyone. You are watching Guru Brahma classes for JEE and NEET. Today's topic is Gibbs energy from the chapter thermodynamics. In this Gibbs energy we are speaking about or we are discussing PYQ of JEE main. Here is the question which is given in 2019. So what is the question? The reaction, there is a reaction. Magnesium oxide is reacting with carbon to form magnesium and carbon monoxide, for which change in enthalpy is given as plus 491.1 kilojoule per mole, and change in entropy is given as 198.0 joule per Kelvin per mole, and it is not feasible at 298 Kelvin. What is the temperature above which the reaction is feasible? What is the meaning of feasibility? So reaction is feasible. What is the meaning of feasibility? Reaction occurring. Reaction occurs. That means here in this we can say that reaction is feasible means reaction is spontaneous. What is that? Reaction is spontaneous. Right? When is the reaction spontaneous? We know that delta G, if it is negative, when there is decrease in the Gibbs energy, then the reaction will be what? Spontaneous. So we have to see that the reaction, for this reaction delta G must be negative. Okay, and we know delta G naught is equal to delta H naught minus T delta S naught. What does this naught represent? Standard conditions. Measuring that change in Gibbs energy at standard condition, measuring that change in enthalpy at standard conditions, measuring that change in entropy in standard conditions. Okay, so this naught represents that the quantity is measured in standard conditions. Okay, so what is delta H given? Let us first of all see that when delta G is equal to 0, then we say that the reaction is at equilibrium. First of all, let us go with the equilibrium, then we shall see about the spontaneity. So from the formula delta G is equal, from the expression delta G is equal to delta H minus T delta S, delta G is 0 at equilibrium. So 0 is equal to delta H minus T delta S. Okay. Now I can write it as T is equal to delta H by delta S, and that is equal to, what do you get? So what is delta H given? Plus 491,100, because it is given in kilojoules, I have converted into joules per mole by delta S for the reaction is given as 198 joule per Kelvin per mole. So mole, joule cancel. Then what you get? You get the answer in Kelvin. How much Kelvin do you get? 2480.3 Kelvin. So T. At this temperature, what is happening? The reaction will be in equilibrium. And we know that delta G is equal to delta H minus T delta S. Okay. So delta H given as how much? 491,100 minus T 2480.3 into delta S, how much? 198. This will be equal to 0. Okay, if temperature is greater than 2480.3 Kelvin, then what happens? Delta G will become negative. If this temperature, see, if this temperature is greater than 2480.3 Kelvin, if it increases, if this temperature is here, if this temperature is greater than 2480.3 Kelvin, automatically what happens? This value will be greater, so that it becomes delta G becomes negative. If delta G becomes negative, the reaction will be what? Spontaneous. Okay. So here, what is the question asked? Temperature above which the reaction will be feasible. Feasible means which occurs spontaneously. So the answer will be the second option. Okay. Next, let us come to this question number 8. We know from first law of thermodynamics, delta U is equal to Q plus W. And we know that work done is equal to minus P external into, okay, delta V. So I can write here it as delta U is equal to Q minus P into delta V. Okay, so Q minus, but the question in this, the question is given as plus. Question asked is, which among the following relations are correct? So this is not correct. Next, from Gibbs theory, we have studied that delta G is equal to delta H minus T delta S. Okay. So this is correct. And from entropy, we have studied that the change in the entropy is equal to Q reversible by T. What is Q reversible? Whatever the amount, this is the amount of heat given to the system in reversible conditions at a particular temperature T. So Q and T, this Q is for reversible process. Some amount of heat is provided to the system at a particular temperature T under reversible conditions. So this is also correct. And relation between delta H and delta U is delta H is equal to delta U plus delta nRT. Here it is plus, but here given as a minus. So it is wrong. So which are correct? B and C are correct. So the option will be first option. Okay. Let us see next question. Here is the question which is asked in very much recent 2024. What is the question? Which of the following is not correct? Which of the following is not correct? So delta G. So we know that delta G is equal to 0 for a process which is in equilibrium. We have studied this. Equilibrium means which reaction will attain equilibrium? Reversible reactions will attain equilibrium. Only reversible reactions will attain equilibrium. Okay, what is equilibrium condition? Rate of forward reaction is equal to rate of backward reaction. For which reactions you will have backward reaction? Only for reversible reactions you will have backward reaction. Okay. So now delta G is equal to 0. First option, let us see. Delta G is equal to 0 for a reversible reaction. Yes, this is possible, because for a reversible reaction, there is possibility for the reaction to attain equilibrium. So delta G can be equal to 0. So this is correct. And we have studied that delta G is equal to negative for which spontaneous reaction. Which reaction? Spontaneous reaction. and delta G is equal to positive for whom? Non-spontaneous reaction. Non-spontaneous reaction. So here given delta G is negative for spontaneous. Yes, correct. Delta G is positive for spontaneous. Wrong. Delta G is positive for non-spontaneous. Yes, it is correct. So asked is not correct. Which is not correct? Third option is not correct. Understood? Okay. Next, let us see the question number 11. The effect of temperature on spontaneity of reactions are represented as delta H, delta S, temperature and spontaneity. We know that delta G is equal to delta H minus T delta S. Okay. Here, first option, let us take option A. In this option A, delta H is positive, delta S is negative. That means delta G is equal to, let us understand it in the form of numbers. Okay, I am taking delta H as some plus 5 minus T I am taking as 1. Let me take it as 1 Kelvin into delta S is minus 4 units because it is given minus. Okay. So then what I get? Plus 5 plus 4, that is equal to plus 9. So delta G is positive. Positive means what does that mean? It is non-spontaneous. So here in the option it is given at any temperature. Let us increase the temperature. If I increase the temperature, then what do I get? Okay, if I increase the temperature, what do I get? Delta G is equal to plus 5 minus, I am increasing the temperature up to 10 for example, into minus 4. So that is equal to minus 5 plus 40, then that is equal to plus 45. So delta G again we got positive. Again what it is? Non-spontaneous. That means whatever the temperature, at any temperature, what is that? If the condition is, what is that condition? If delta H is positive and if delta S is negative, at any temperature, the reaction will be non-spontaneous. So, option A, whatever the conditions are mentioned here, that are correct. Right? Next, coming to option B. Let us see option B. In option B, delta G is equal to delta H minus T delta S, right? That is equal to delta H given positive. Let me take it as plus 5 minus of 1 into delta S. Delta S is again positive. Plus 4, let me take it as that plus 5 minus 4, that is equal to plus 1. So plus 1 delta G is plus you are finding. What does that mean? It is non-spontaneous. So let us increase the temperature. If I increase the temperature, delta G is equal to delta H minus T delta S, that is equal to plus 5 minus of, what is that? 110 into plus 4, let me take. That is equal to plus 5 minus 40, that is equal to minus 35. Okay, so you got minus, that means it is spontaneous. So what condition? Non-spontaneous at low temperature. What is that? At low temperature, non-spontaneous. So here given at low temperature, it is spontaneous. So it is wrong. Okay, it is spontaneous at high temperature. At high temperature, it is spontaneous. So here asked is, in the second option, you can find the conditions provided. The conditions provided is low temperature. So that cannot be the correct. Okay, wrong. Next, option C. So delta G is equal to delta H minus T delta S, that is equal to delta H is given as minus. So let me take minus 5, 1 into, this is minus and this is also minus. So minus 4, let me take. So minus 5 plus 4, that is equal to minus 1. So you got minus 1 delta G. That means it is spontaneous at a low temperature. Spontaneous at low temperature. What about at a high temperature? Let us see. Delta G is equal to, right, minus 5 minus of 1 into plus 4. See, the same condition, no? Which condition? Third option, third condition. So minus minus 4, right? Here I increased the temperature up to 10, right? So then what you got? Minus 5 minus into minus plus 40, that is equal to plus 35. What did you get? Plus, that means non-spontaneous at a high temperature. The high temperature it is non-spontaneous. Understood? Then coming to option D. Option D. So in option D, what are the conditions? Here let us see, at low temperature it is non-spontaneous for third option, non-spontaneous. At low temperature, you are finding at low temperature it is spontaneous. So this is also wrong. Right? Coming to delta G is equal to delta H minus T delta S. Again, the conditions are fourth option, minus 5, 1 into plus 4, that is equal to minus 5 minus 4, that is equal to minus 9. So spontaneous. Let me increase the temperature. So if I increase the temperature, minus 5 minus 10 into 4, that is equal to minus 5 minus 40, that is equal to minus 45. Again minus, that means spontaneous. So spontaneous at all temperatures. At all temperatures. So if you increase the temperature, or if you don't increase the temperature, it is found as it is. This is minus, delta H minus, and T delta S is also minus. Minus minus adding, you get overall minus. Again you are getting overall minus. So that is the reason why, what is that? D option is also correct. So D, conditions for D are also correct. So what is the question asked? This question is asked in 2025, very recent examination. And the incorrect combinations are incorrect. Incorrect are B and C. That means B and C. Where is B and C? So in the fourth option, you find B and C. Okay. Right. Let us see the next question. Here is the question, which is asked in 2025. Let us see that. Here are two lists given. One is partial derivative list, another is thermodynamic quantity. Thermodynamic quantity. So you are given how to solve this. Let us see that. We are speaking about partial derivative of G by partial derivative of T at constant pressure. Here partial derivative of enthalpy by partial derivative of temperature at constant pressure. So in that way, these are given. How to solve this? We are speaking about G. We know that from Gibbs equation, if the change in the Gibbs energy is very small, infinite small, then we can write that dg is equal to dh minus t. We have an expression. First of all, let us see. We have an expression. What is that expression? G is equal to h minus ts. This is the expression according to Gibbs. Okay. If there is small change in G, then there will be small change in H minus dTs. Okay. Differentiation or d into Ts gives you what? dg is equal to, right? dg is equal to dh minus t into ds plus, right, s into dt. You can write d into ts gives you t into ds plus s into dt. Temperature into change in entropy plus entropy into change in temperature. So what I can write? That is equal to dh minus tds minus s into dt. dg is equal. And we know that H is equal to U plus PV. We know this. Small change in H gives you du plus d into PV. Okay. d into PV. Then what will you write? dH is equal to du plus P into dV plus V into dV. Right? Change of P into V is equal to P into change of V plus V into change of P. So let us substitute this equation. For example, let me take this equation as 1, this equation as 2. Okay, let me substitute this equation 2 in 1. Then what do I get? dg is equal to du plus p dv plus v dp minus t ds minus s into dt. Okay, instead of dh, I have used this du plus p dv plus v into dp. Then what do I get? We know that from first law of thermodynamics, I can write du is equal to q reversible plus work done reversible for a reversible process. For a reversible process. And I can write that du is equal to, for a small changes, very small changes, minus p into dv. So substituting these things under du, let it be equation 3. Under du, I substitute this, then I get dg is equal to q reversible minus pdv plus pdv plus vdp minus tds minus s into td. S into dt. So minus pdv plus pdv gets cancelled. And we have studied from entropy that ds is equal to q reversible by t. And q reversible will be equal to t into ds. So use this equation 4 in this equation, and what do you get? dg is equal to q reversible is t into ds minus v into dp minus t into ds minus s into dt. So t into ds minus t into ds gets cancelled. Then dg is equal to, okay, minus, this is v into dp minus s into dt at constant pressure. What I am speaking about, at constant pressure dp is equal to 0. Change in the pressure is equal to 0. Constant pressure is maintained constant now, so change in the pressure will be equal to 0. If pressure is equal to 0, I can write dg is equal to minus s into dt. So this can be written as dg by dt is equal to minus. In another way, partial differentiation method, if I write, I can write it as partial differentiation g by partial differentiation into t, okay, at constant pressure is equal to minus s. So this is happening at constant pressure, right? dp is equal to 0, constant pressure. So partial differentiation of g by partial differentiation of t at constant pressure is equal to minus s. So we got the expression. Where is that? Minus s. So A2, right? For the same expression, if I take at constant temperature, so this is also given, you see, at constant temperature, the same expression you take, this expression. If I take this expression, what is that expression? dg is equal to v into dp minus s into dt at constant pressure, at constant temperature. That means dt is equal to 0. If dt is equal to 0, I can write dg is equal to v into dp. Okay. Then what I can write? dg by dp is equal to v. In another way, partial differentiation method, I can write del g by del p at constant temperature is equal to v. This is at constant temperature, no? Okay. So now you see, this is happening at constant temperature. Then what is the answer? C4V. Then what is asked? dH by T and du by T. Right? So dH by T and du by T. Let us see dH. And we know that H is equal to U plus PV. dH is equal to du plus PdV plus V into dP. dH is equal to, right, du can be written as Q plus, what I can write, Q reversible plus, right, work done, plus P into dV plus V into dP. Work done can be written as Q reversible plus, work done can be written as minus P into dV plus P into dV plus V into dP, right? So dH is equal to, so P into dV and P into dV gets cancelled, right? So then what you are having, dH is equal to Q reversible Q, right, plus V into dP. But what is asked here? dH by dt. What is asked? dH by dt is asked. We know that Q is equal to C into dt. C into dt for 1 mole. For 1 mole. Because Q is equal to NC into dt. As N is equal to 1 mole, I can write Q is equal to C into dt. So I can write dH is equal to C into dt plus V into dP at constant pressure. What I am speaking, at constant pressure, dP is equal to 0. That I can write dH is equal to C into dt. dH by dt is equal to C. And as it is at constant pressure, I can mention it as Cp. So Cp. So if I write in partial differentiation method, I can write del H by del T at constant pressure is equal to Cp. Okay. So where is the option? Let us see that. Where is that option? Del H by del T at constant pressure is equal to Cp. So B1, sorry, B1, A2, C5, C4, B1, A2, okay. Then we have to know the other one, del U by del T at constant volume is equal to Cv. You have to derive that, right? So let us see. We know that du is equal to Q reversible plus work done. So du is equal to Q reversible minus P delta V, right? Then I can write it as, and we know that Q reversible, already we have seen Q, or Q, directly you can write Q. So Q is equal to NCV delta T at constant volume. At constant volume, right? So substitute this at constant volume. At constant volume, what I can write, dV is equal to 0. Substitute in this equation, then what do you get? U is equal to Q. Instead of Q, what you can write? Instead of Q, what you can write? You can write, if number of moles is 1, I can write CV into dt. So du by dt is equal to Cv. And as this is at constant volume, I can write del U by del T at constant volume is equal to Cv. So del U by del T at constant volume is equal to Cv. So A2, B1, C4, and D3, D3, so D3. So what is the answer? First option is the correct answer. Okay. So thanks for watching. We'll meet in the next session with a new topic. Thank you.